All right, example 3, partial fraction decomposition of this into simpler fractions. Step 1, see if it's improper. It is not, hooray. Step 2, factor the denominator. So we're going to rewrite it as 2x squared minus 5 over x times x squared plus 1. Notice that this guy is quadratic, x squared plus 1. It just has an exponent of 1 though, so we don't have to worry about repeating stuff. So it's our job to write this as something over x plus something linear, bx plus c, so that's linear, like y equals mx plus b, over the quadratic guy. So common denominators means this first guy gets multiplied by x squared plus 1 over x squared plus 1. The second guy gets multiplied by x. So denominators are all the same. The numerator, 2x squared, minus 5 equals ax squared plus a plus bx squared plus cx. Reorganizing, 2x squared technically plus 0x minus 5 equals a plus b, those are both x squareds, plus cx plus a, just organizing stuff. So 2 equals a plus b, 0 equals c, that's nice. Negative 5 equals a, that's also nice. So we know c and a, but we don't know b. So 2 equals negative 5 plus b, add 5 to both sides, b equals 7. We've got all we need. So my partial fraction decomposition is a over x, so that's negative 5 over x, plus b times x plus c, so 7 times x plus 0 over x squared plus 1. So that is my partial fraction decomposition of this guy. Let's do the second one since we've got time. Okay, on to example 4. All right, step 1 is this guy improper. When you first look at it, you might think it is. The degree of the top is 3. But if I were to square this denominator, I would get, so x squared plus 4. I would get x to the 4th plus some other stuff. So we can see that it's not improper. So step 1, check. Step 2, the denominator has already been factored for us. So we're just going to leave it as x cubed plus 3x squared minus 2x plus 7 over x squared plus 4 squared. So it's our job to rewrite this guy. Notice we've got quadratic terms in the denominator. So I've got to have linear terms in the numerator. So I need an ax plus b over an x squared plus 4 to the first power. Don't really need those parentheses, plus a cx plus d over x squared plus 4 to the second power. Okay. Now I've got to get common denominators. So this guy is missing another x squared plus 4. So is the top. The plus this guy is just fine. So this cx plus d doesn't need anything. My denominators are all the same. So x cubed plus 3x squared minus 2x plus 7 equals, if I multiply, I get ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. So if I reorganize stuff, I've got an ax cubed, that's it. I've got a bx squared, that's it. I've got a 4a and a c that are being multiplied by x. And I've got a 4b plus d that are by itself. So matching up coefficients, a is 1, b is 3, 4a plus c is -2. And 4b plus d is 7. So we've got a system here. It's not too bad to figure out. Again, you could solve it using matrices on your calculator, but since I know that a is 1, this guy becomes 4 plus c equals -2, subtract 4, so c equals -6. Down here I know that b is 3, so 12 plus d equals 7, subtract 12, so d equals -5. So, rewriting my answer here, 1x plus 3 is my numerator of x squared plus 4, plus -6x minus 5 is my numerator of x squared plus 4 squared. Just a note, the textbook might be finicky when you input stuff like this, so for this answer, the textbook actually writes it like this. Down here. X plus 3 over x squared plus 4. And they actually factor out the negative here, so they say that it's minus 6x plus 5 over x squared plus 4 squared. So if you've got a negative in both terms, be careful how you enter it. If they count it wrong the first time, hopefully they'll say, hey, think about factoring out a negative, but just think about different ways that you can write your answer.